Alrighty, happy Thursday. Sorry again to miss you Tuesday. I was definitely not in any shape to be here Tuesday, but after I got off the good pain meds, I'm cleared to drive and do all that good stuff, so I'm here. A little tired, sorry. Probably be a little lower energy than I usually wanted, but that's okay. So from objects and classes, we got a little bit started last week, which was nice. So we want to dive into the inheritance side of things with this and look at how inheritance works with objects and classes. And that'll be sort of the bulk of our first project, is using classes, using inheritance, and then the fun things we get with pointers as well. And then exceptions is my favorite way of working with classes. It's the preferred way of working with classes to communicate issues and things. We'll practice that in our coming lab the following Tuesday. And that should go pretty well for us. We'll be able to get into that, get into our pointers, and then I think probably Thursday we'll get into the project, be able to get that out. So we'll have 2 weeks to work on that. It'll be due 2/6 before class starts, because the first thing I'm going to do on February 6th is go over the solution. And most people seem to think it's worth their time. If you think it's a waste of your time, please tell me. Like I don't have to do these things, but just let me know. It'll probably take me about half an hour or so. Don't feel bad if it takes you longer, because you haven't been doing it for 20 years. That's okay. You're here learning how to do it. So ideally, it does take you 4, 5, 6 hours or so. It's a chunk of work. It's not impossible. It's just going to take some time to do it, to go through the motions and then go build this stuff out here and practice some of those things we're going to talk about. So we'll do objects and classes, and then we'll talk about testing as well. In Mac land, it's a little different. There's different tools or libraries you can use, or if you're on a Mac, we can just do it the ugly way in a main file. It's okay. It's not the end of the world. Using the tools is really nice and cool, and we can get some fun stuff going. I don't think we'll have enough time to do it. We used to do a lab where we can get some automated testing running. We'll see if we have time to do it, but you can do cool things where you can make your tests run in the cloud and then get some cool history in GitHub and do fun things there. But it's probably more than we want to bite off at this point now. Somebody fire up Visual Studio. Sorry, I should have hit start on that a little sooner. I forgot this one's slow. Okay, make a new project. Again, if you put your project in the repository, it can go track it. If you don't put it in the repository, like the source repos folder, GitHub has no idea where it is because it's not in its folder, right? Git only knows how to watch the folder that it started in. So I think, yeah, it's in my recent history here. I'm just going to put it in this folder here, and we'll call this week 2 OOP. So it's in my week 2 folder here then, right, inside of that repository, and then Git can go watch it. So I can open up my GitHub desktop client. Let's go find 200. And now it should say, hey, there's new stuff here, right? The week 2 OOP folder, the week 2 OOP CPP file. Yeah.
You can't see it.
Thank you. Yeah, I plugged it in, but didn't click the button. That would be useful. Yeah. So yeah, one more time. New project. When you put the new project in here, pick the folder. Make sure it goes in that right location. Thank you. I can see the screen. Why can't you? I told you I'm a little tired. All right, so if you see the new stuff here, this is good. This is the right way. You can get away with making it and then copying and pasting it or cutting and pasting it. That's the hard way. Try to avoid that. Just put it in your repository and life is good. Right? It'll be much easier than trying to go putting in the repository later. And then, of course, nobody's using the file upload option because that's just awful. Well, we shouldn't have it, but I can't turn it off because it's not my website. Okay, so we've got it here. We see our other files, our solution file, VC proj file. This is our C++ project file. Just let them change if they change, right? We don't really care anything about those. As long as I got my CPP file, I got my code, we should be good. Having the rest of it out there is nice. Again, if you're using Xcode or some other tool, you'll have some other garbage out there, that's fine. On Mac, make sure you get the correct ignore, so it ignores the right stuff. The one for Visual Studio doesn't work for Mac. Right? I think I showed, there's like a link. You just go Google C++ ignore for Mac. You can probably find a good hit there. And we can go update that. All right, Look, did you know this one has a main function? What a helpful comment. This stuff is garbage. Garbage. All right. So here's our starting file. So we want to go make some classes. Again, I showed you I'm a little bit lazy in that I like using header files, but I'm going to put all the code in the header file rather than a header file with the declarations and then the CPP file with the implementation. That's the right thing to do. Okay, we all acknowledge it's the right thing to do. We're just not going to do it because it makes the next step of this harder, right? Oh, that hurt. We didn't get to the next step yet, so we're going to do that. So last week we left off. Let me actually go open that because I don't remember how far we got here. Documents, GitHub. Oh man, I have 2 documents folders now because that's fun like that. 200. Nope, 200. Got excited. Sure, save. All right, we got our Powerball ticket. We didn't actually test anything out. We didn't see if it worked at all. This one's a little harder to test. It is testable because we can give it specific numbers if we wanted, and we never got to that to-do to make sure it was valid. So this one we could go and test. So maybe we'll start with this one. So I'll modify some of the week 1 files, and we can come back to it later. So it'd be nice to know that our get winnings works, right? Just because any code that's worth writing is worth testing. Right? Making sure it does what you think it's supposed to do, what you think you told it to do. You want to make sure it does that, right? Because you run your code, and the only thing we've done so far is we run our code and say, okay, if I plug in A, I get B out. And then we have to look at it, hit run, type in A, and look to see if it gives us B. You know who's really bad at making sure that output matches? Is people. People are really bad at that sort of thing. Have you ever tried to proofread an English paper? How many times do you have the word the in there twice or something like that? It's really hard. Thankfully, Word flags it for you nowadays, but it's hard to see things when you're expecting something. So you know who's really good at saying does A match B? Is a computer. So what we're going to do is we're going to offload that work to the computer, and because we're programmers, we're going to do it with code, which is lots of fun. So we're going to go make some tests for this class here. So there was a shortcut. I think it works if I say, where did it go? Oh, what was my shortcut for this? Go to, is it this one? It's not. Where was it here? No. I think we have to do it the slow way. That's okay. Do we have, is it a quick action? No, okay. That's fine. So we have Powerball ticket. So we're going to make a test project. And this is specific to Visual Studio. You can do very similar things in a main function if you don't have Visual Studio. And I'm sorry. Again, there's ways to do it on Mac. I've Googled it. I've never done it because I don't own a Mac. The college didn't buy me a Mac. Put that in the end of the semester survey, by the way. They should buy me a Mac. Maybe one of these days it'll work. So remember, a solution is one or more projects. At this point, we've only ever done one project per solution. But the way it's designed is you can have more than one project. So we're going to add another solution here. So I'm going to go add a new project. So at the solution level here, not at the project level, at the solution level, I'm going to go add a new project. And if I just go search for test here, we get a native unit test project. I think this Google one works on Mac. Again, I've never tried it in Mac land, but again, they don't use Visual Studio. So we're just going to do native C++ unit test. And now this one uses the Microsoft CPP unit test framework. It's specific to Microsoft's Visual Studio product. There's other test frameworks like the Google one and all sorts of other things you can use. We're just going to do this one here. This is, again, easy enough here for now. And it says, okay, we're going to put it in this spot here, adjacent to your other solution, or adjacent to the other project. What do you want to call it? The default is fine. You can name them very specifically. I want a unit test Powerball. That's a bit of extra typing. I don't care to type. So I'll just say create. So now I have some code here. So here's the unit test project with a bunch of stuff here, the PCH, I don't know what that is, that's fine. But here's my unit test file, that's the one I really care about here. It's a test class, right? We're calling it unit test 1. And here's my test method, we're calling it test method. It uses this namespace to let us do a bunch of things here. It includes my header file, which doesn't actually look like it's anywhere, don't worry about it, it's okay. Right, that's part of what we're inheriting. So what we're going to do in here is we're going to arrange, we're going to act, and then we're going to assert. This is just a convention for how we organize tests so that they're very nicely, easily readable. You don't have to follow it. It's just, if everybody does it this way, it makes life easy for everybody. because we know what to expect. So this is a relatively common convention people use in the industry. We're going to arrange our variables. So we're going to set up the things we need to test. So this is setting up what we need to test. Then act is actually calling the code for testing and getting results. And then the assert is, did we get what we expect? Yet we expect. Okay? So to set up what we need to test, I'm going to need 2 Powerball tickets, right? And I need to know how much I think I'm going to win, right? Because we want to test that get winnings function. Does get winnings correctly calculate the right amount of winnings given a set of matches, right? If I had 3 whites and a red, I get some prize of whatever it happened to be, right? I want to test these things here, right? So this is, and then instead of test method 1, we'll call this get winnings here. So just naming it nicely here is helpful. So you have a nice name, right? Names are useful. You want your code to be meaningful. So we'll have an int for expected winnings. Then how about we start with the jackpot, right? Should we do that one? So we said our jackpot should be worth about $1 billion, right? Whatever that one is here. So we'll say here's our $1 billion. That's what I expect to win. Then I need some ticket and the winning ticket. So I'm going to say I need the Powerball ticket class. Oh, well, I don't have access to it. This is where making stuff in the H file makes our life a little bit easier. So what we're going to go do is we're going to go include this one. We're going to go reference this project in another project. So say, hey, all the things from over here, I want to use over here. So it's not just the include because it's in a different location. So we're going to go add a reference. So this references section we probably never touched before. We're going to go add a reference. Say, hey, I want to reference this week 1 OOP project. Hey, you want to reference another project in the solution? Yeah, this project should know about the other project. Now I can go include my Powerball ticket. Is it not? Do I have to go up? // hang on, where did it go? Include, added it. Include, nope, hang on. I had the .. Okay, here's the file we're in here. Week 1 OOP, there we go, Powerball ticket. So I want to go reference a file in another folder. So some of that Unix stuff we did is slightly helpful, right? .. means up a folder, right? If I go look at where this is now, all the unit test stuff is in a unit test project folder. So from its location, it has to go up a folder to get back to my repository here, right? I can show an Explorer. So here's the main level. The unit test 1 is here. So I have to go up a folder. So we go up 1, then we go into week 1 OOP and find our H class. So it's just navigating around, saying, hey, go look in this location, right? Now we can go include it. So I'm including it, and then because it's all in the H file, it's essentially copy pasting all the code here. Life works out really nicely for us. Should be pretty good. Now I should be able to make a Powerball ticket. So we'll say my Powerball ticket, here's ticket equals a Powerball ticket, and we have to give it the vector of numbers, right? So maybe we need to make some numbers. So this is vector of type int for numbers is 1, 2, 3, 4, 5, 6. Sure, very exciting vector of numbers here. Given numbers. And then we'll make a Powerball ticket. The winning ticket is a Powerball ticket. And maybe we'll do this. This is a little silly, but it's going to make it easier for when I copy paste in a second. We'll say the winning numbers. We'll do that 1, 2, 3, 4, 5, 6 again. So we'll have my ticket with my numbers, and we'll have the winning ticket with the winning numbers, right? So we've set up everything we need, right? We've arranged all the things we need for our test. Then what we're actually testing then is our get winnings function. So then we'll have an int for the actual winnings. Actual winnings is ticket.getWinnings. Ticket, come on. Int, come on. Ticket dot. Did I not? Am I missing a semicolon? I'm missing a semicolon. Thank you. That would be nice. Ticket. Now I can call get winnings. I should have known that, but that's fine. Here's the winning ticket. Okay. So we call the code we're testing and get the value. Right now I've stored it here. Now I can assert. So to assert, we say assert equals. Oh no, shoot. Assert colon assert are equal. So the assert scope, right? There's a little scope operator here, like we're doing an implementation thing. That's sort of fun. And And then what do we expect here? So this was the expected winnings, and the actual winnings. So we're going to compare, make the computer look at those two numbers and tell me if they're right or wrong here. Now what's fun, I have a cool test menu here. You've probably never seen it before. You can go to Test Explorer. You get a new window here on the left usually. So this is the Test Explorer from the test menu. And you say you want to run all the tests. Oh, we got to build first, sorry. So go run all. So let's go build solution. Then we should be able to click run all. There it goes. Now we've got a test here. So now that we hit build, it went and figured out, we hadn't compiled the code yet. Now I should be able to run my test here. We can see test get winnings. Come on, run. There it goes. And it passes. We get a nice little green check mark here. Right? So if we put a different number in here, like 0, and then went to run the test, it's going to fail on us. And what's really nice is it's going to show us a nice little message. It says, hey, expected 1 billion, actual value is 0. Right? So you get a nice error message here showing us what went wrong, where, right? Oh, unit test line 13. And what you can do is you can debug from the unit test. So if you wanted to, you can go debug your test. Is it debug test? Somewhere, debug tests. And it's going to pause, just like the debugger does over here, and I can step through, so we can step into if we wanted. So this is where the into is useful instead of over, right? If you want to go into your function calls, you step into. So now we're going to step into the get winnings function, and I can see, hey, I've got this instance here, has numbers 1, 2, 3, 4, 5, 6, and I have the winning ticket, has numbers 1, 2, 3, 4, 5, 6. Okay, they look like they should match, right? This sort of thing. Life is good, and you can step through your functions and have all sorts of fun debugging there if it's not doing what we expect it to do. You know, in our case, it did work, which is nice. So we'll put that back to the actual winnings. So this is get winnings. Really, this is the jackpot, right? Now, I wrote a bunch of code for a bunch of other winnings. Kind of want to know if those work, right? If it's useful for us to write it, we want to make sure it does what it's supposed to do. So we're going to copy paste a whole bunch of crap. And that's okay, right? Don't worry too much about it here. We're just going to go copy paste. Oh, this chair is the worst. Ow. Sorry, moving still hurts. We'll get there. And then you even get these nice little visuals. Hey, this test was failing here. And then you can go run it again or whatever you want, which is fun. Yeah.
Can you explain when you did assert? Like, what does the assert thing do?
It's saying, hey, do these things match? So the assert comes from that library, the test framework library, that does all the cool things and gives us that visual view. It's the library way of making sure it works. So what you would do in a main method, right, if you don't have Visual Studio, we're going to go add a new source file here. I don't know, call it main or something. Source CPP is fine here. And then we would, oh goodness, that's too big. So we'd include vector, and we'd include Powerball. Seriously? What is going on here? Powerball ticket.h, it should be there. All right, now the red line goes away. I don't understand Visual Studio sometimes. It's okay. Using namespace, standard, and int main. We could do all the same sort of stuff in a main function here. Where's our test? Here it is. But it's not going to be as pretty because you don't have this assert r equal. I think there's a different assert you can use, but it's awful. What is it? Assert? Isn't it? I forget what it's called. So we could essentially do a stupid, if this matches, then cout jackpot. Or whatever, we lost the method name here, jackpot test. Passes, else, oh goodness. Stream, thank you. This is the starter code, and then line, otherwise fails. And this is still awful, but you know, it's okay. It's not as pretty. You don't get the nice green check marks and red X's, and then we can't automate it anywhere. But if you're on Mac land, you can do this, right? Oh no, that's equals here, right? If expected winnings equals the actual winnings. And this would do the same thing for us here. We should be able to run this, and it should just output now, pass or fail. What? Main? Oh, okay. I already had one with a main function here. Okay, I just called it weak 1 OOP. Shoot. Okay, so it's not going to run because I have two things called main in here. we'll do this. Here, drop it over here. So before we return 0, we'll just do it up at the top here. So here's the testing without Visual Studio. Sure. And I can go delete that file. Sorry, I forgot I already have one with main. So let's delete that one and give that a run. Oh no. We already had one called the winning ticket. Okay, sure. Winning ticket test. Winning ticket test. Okay, now I do it. Okay, there it goes, and it passes. Yay. We expected it to. Right? So if you don't have Visual Studio, you can do it this way. You're just going to have a bunch of these. Okay, if they match, we say it passes, otherwise it fails. Here, sure, it'll work out here. I will argue this is way better, and there's lots of other cool bells and whistles we can attach to it. I'll show you later. That's why this is the superior method, right, of doing unit tests. Then we need to do this again and again and again and again and again, because Powerball Ticket has 1, 2, 3, 4, 5, 6, 7 different winning returns, and actually 8 and 9, because we want to test these options as well, make sure they work, right? So 9 different other tests that we have to write. But we want to know that the code works, right? It's worth doing. So this is the jackpot. So let's go copy all of that here. We just go drop another one in, and we just need to change this name here. So this is test winnings million here. So that works if the white number was different, right? We know that from actually having written the code, right? If you have 5 white matches and not the red match, that ought to work. And then this should be a million then for our 6 zeros here for our expected winnings. And that one should be fine. So we can go and run our tests. We should get that in the test explorer. And now the millions passes. Life is good, right? And we'll go on down. So here's the millions. And then the next one, I guess we can take out some of those extra white spaces here, right? Then we'll go and do the next one down, which was 50,000. Get winnings 50K? Sure, why not? So that's 4 match and the red. So I'll put the red back to matching, and I'll make this one not match. Right, 4 matches and a red match ought to be for that. And then let's give that one a check. Oops, sorry, that was the wrong button here. Run tests. Did it show me? Okay. Oh, 50K didn't work. Oh, I forgot to change the expected winnings here. That would be an issue. 50K is this one here, right? 50,000? Okay. Let's try that again. Now let's run that test. Hey, that one passes. Nice. All right, let's do it again. So there's 50K. Oops, that didn't look like it copied right. Oh yeah, there we go. So we did 50K, then we need to go down to $100, and there's 2 different ways to match 100. So 100, matching 100, 100, I don't know, 1. This is the first method here. So you can win 100 with 4 white or 3 white and a red. All right, so we can do the 4 white first here. I keep wanting to go back to a different tab here. So 4 white match, but not the red, right? That should be the 100. That's one way. Or 3 white and a red. So 3 white, then let's change this one then to, I don't know, a 7. But then the red should match. Put that one back to a 6. So the first 3 match, right? Probably at one point we should test the sequence doesn't matter. Maybe we'll do that with the jackpot. I don't know. Put these in reverse order. 5, 4, 3, 2, 1, just to make sure that part works here. Maybe you'll feel a little better about it. But that should do it for us here if we go run our tests. Oh goodness, build errors. No, what do we do here? Get winnings. Oh, this was already defined. It's already declared a function with that name, so I got to change that one to 2, right? Here's the first version, here's the second version. Probably be nicer to add in 3 white and a red. I don't care to do that right now. That's fine. Let's go run our tests. And did that one work? Run that one too. Hey, all right. So that 101 works. 102 works. We're doing good so far. It's not so bad, right? We're copy pasting. It's not a lot of hassle. There's some fancy ways to make this easier to not have to copy paste as many things. that's also a lot of work to do, because then you have to like set up a bunch of other cases and switch things. And honestly, I don't feel too bad about copy pasting this, only a little here. So then our next test then, right, was if you didn't win $100, you could win $7, 2 different ways. So with 3 white or 2 white and a red. So this is 7. Why do I keep going back to that? So this is winning 7-1 with the first version. So matching, what do we say? I already forgot. 3 white, but not the red. So 3 white, but not the red number. So put the red number off. Wins us $7, right? Or the other option then was matching 2 white, but the red does match. So put the red back and then move this one up to like 8 or something, right? So we're not matching that one. Right, so 2 white and a red, or that one. So let's run those ones here, see if those ones pass. Check our test explorer. We should get the 2 new ones. Might not be clicking the right thing to run them all. That's fine. There, and they both pass. Life is pretty good. The last one we wanted to test here was winning $4 here. Win 4. And that's just the red number matches. So none of these match, right? 8 and 10, right? If only the red number matches, we should win $4 here. And then we might as well do the 0 as well, right? Because that is a most common occurrence is you win nothing. So you should get $0 back if none of these suckers match. We'll say, I don't know, a 1 for the white number. It doesn't really matter here. I like 5. Now they're all in order, right? And I can go run my tests, run all my tests. Oh my goodness, really? Oh, this is 0, not 4. There we go. Run all of our tests. We should get some more tests. I didn't run all, actually run them all. That's fine. Run, and they pass. So now I've actually executed the code, right? All of the code has been exercised in checking this out, which is nice. So there's tools you can pay for, which we're not going to do, but they sell them in the industry, that measure the amount of code that's run in your unit tests. This idea, we call it code coverage. How much of your code is being tested, right? If we would have stopped at the jackpot here, we wouldn't have tested these lines, these lines, these lines, these lines, these lines, these lines, right? That code wouldn't have been covered by a test. That's why we call it code coverage. How much of your code is covered by a test? So technically, just in either one of these would have given us code coverage for these tests, because that line of code was tested, but we didn't actually test all of it. So it's not a perfect measure, but it's a pretty good measure to have. So to talk about code coverage, obviously the goal is 100% code coverage. Every line of code you wrote should be exercised at some point in a test somewhere. Because if it doesn't matter if it works or not, don't write it. You're wasting your time. If no one cares if it works, don't write it. If they care if it works, go and test it. Make sure it works, right? And again, that's, I can stand up here and say that in the industry, it costs money to do these things, because it's your time, energy, and effort that go into writing tests, and then you have to maintain the tests and these sorts of things. And some people say good enough is good enough, and that's fine. Like, not getting to 100% is not the end of the world. The amount of gain you're going to get from getting from no testing to like half your code being tested is huge. To go from half your code being tested to like 75% of your code being tested is a smaller return. You're going to get more value out of it, but not as much as testing half your code, right? So to go from like 90% of your code being tested to get that last 10% could take a lot of time, energy, and effort. You can see this takes a little bit of time to go and write these tests, right? And again, with more complicated things, you have more complicated tests. This goes in, this comes out, that sort of thing. So it's okay if you don't get to 100%, but it's definitely a good goal. It's an aspirational goal, right? In some companies, they'll say 100% or nothing. Go for it. That's great. Some companies say, hey, we don't have enough money to pay you that many hours to test all of the code. Just pray it works. Or, that's a bit of a joke, but, it's probably fine for every single set method and every single get method to not have tested them, because they're set and get methods and they're dull, right? You want to test the interesting things. So focus on the interesting stuff. We focused on get winnings. That's the interesting piece here. We didn't actually test whether or not didn't we have like a string here? We didn't test if our toString works. I don't really care too much. I care a little if this works, but again, it's not the end of the world. It's not a really interesting function to test. We didn't test get numbers. Does this work? These sort of things should just work, right? It's possible we typo and screw it up. We'll probably find that somewhere else much faster. These other sorts of things here. Does that make sense? Okay, cool. So that was our basic bit of testing with this. If you've never done unit testing before, that's okay. And again, we're testing at a small unit level, typically function by function, small pieces here. There's different levels of testing you can learn all about in the software engineering class, which is lots of fun. But the next cool thing you get to do once you have tests is you can implement something known as continuous integration testing. As code is integrated into your environment or into your code base, you test it. This is super common. Everybody, if anybody, should have this sort of thing. So if we go to GitHub and look at Microsoft's VS Code repository here, it's an open source tool. VS Code's fantastic. You can actually see the tests that are being run on every 128,000 commits. And then this is something GitHub offers in addition to the cool things Git does. This is one of the reasons people like this tool is, hey, this commit happened and 42 out of 46 tests passed when this change was put into our code base here. Oh, well, something didn't work right. What's going on here? So you can go click it and actually view it here, what's happening. Oh, it just timed out or had other failures. I don't actually know what most of these things are. It's not my code base. I don't test this one, but you can go and see visually, which is super nice. So we can add hooks into our source control tools that say, when the source code changes, go run some subset of tests, all of the tests, whatever we want to define here. So this is the GitHub Actions piece. That's one of the big selling points of GitHub. And all the other tools have them essentially. There's different ways to set it up to make it work. So something watches the Git repository to say, hey, when it changes, go run some tests and tell me what happens. So other times these things pass here. Oh, hey, 8 out of 8 tests pass, 18 out of 18 tests. I don't know why they're different. Again, you can all do all sorts of crazy things with your Git actions and look at specific things, and probably depending on what changed where, they run different tests here. 47 out of 47 tests pass. And you can go and see the details. You're like, oh, okay, hey, this one did its thing. I don't actually know. There's warnings here, but they seem to pass. I don't know, you can click on them, and it gives you a nice little environment for viewing it. So if we wanted to, which again, I don't think we've got the time, energy, or effort at this point to do it, but you could go and set up a repository and set up the actions to go and run your tests and say, hey, when my code changes, please go run my tests. It's a little bit of setup, but having that done then means that someone else's computer, you use a cloud instance, goes and runs the tests. I don't have to wait for the tests to run on my computer. Now, our unit tests were fast, but as you can imagine, you get larger and larger, more complex code projects, it's going to take a little longer to run those tests. Right? And there's different levels of testing you can do. Right? I can do some integration testing. Does my piece work with another piece? Not just does my piece work. Right? Does the integration between the two work? Can I test the whole system from end to end? Right? Those sorts of levels of test you can build out in the cloud and say, hey, go run these things every time my code changes, because it would take me half an hour to run on my machine. That's not really a good use of your developer's time. Every time they make a change, to sit around for half an hour and look at it spinning. Be like, does it work? Does it work? Does it work? Right? We want to pawn that work off like we did. We pawned work off on the Unix server to make it go do something else. You do that same sort of thing. Go put it out. Someone else's computer will run the tests for you, and you'll get the results back later. Right? So that's sort of the fun conceptual piece of why I want tests to be done in code. Right? Having to go and look at my main file and say, did I get a pass or a fail? It's not going to cut it. You can't integrate that into a system very easily and have it go. You could. It would just be a lot of energy and effort to do that sort of thing. You're like, oh, now some tests failed. You made some changes here. Right? So we're codifying the behavior here with our tests. So the next level of this, and again, it works for different software, different environments here, is continuous deployment. If you can pass all of your tests, you should feel pretty good that you can deploy your software and give it to your customers. This works most easily for web applications or websites. Right? You just update your website. So you can write code that automates the updating of your website. So my friends over at Khan Academy can update the khanacademy.org site 20, 30, 40, 50, 60 times a day, because anytime they make a change in the code, it goes through the tests, through continuous integration, moves to the continuous deployment, and their website gets updated. So they make it fast for their developers to get code into users' hands to see if it's doing what they expected it to do and working, solving that problem, making them money. They're a nonprofit, but they still need to make money, right? Essentially, by delivering a service and convincing people they're doing a good service here. So the faster your developers can get things into people's hands, the faster you can make money, right? For different tools, it doesn't work out quite as well, but I don't know if you notice some of our tools auto-update. Discord loves to do that, like, oh, hey, Discord has to update next time you hit close. Sure. I don't know what they do all the time, but they're able to ship changes. I feel like it's every day. It's probably not every day, but like at least once a week. It's like, oh, Discord has to do a quick update. Like, okay, sure. That's fine. So a lot of our tools are built around this idea that I want to be able to update them frequently. Now, that's bad if you run security software that crashes Windows. What was that? Was it last year? Man, 2024 was last year. Was it CloudStrike? Was that what it was? CloudStrike outage. Yeah. This was it. It has a Wikipedia page now. July 19th, the day which will live in infamy here. They did an auto update on their software and bricked 8.5 million crashes or systems because their updates sucked. It was a quick fix, but you had to go touch every computer, which is kind of hard, like for these like kiosk style computers. So it's a bad day for tech support. So again, it's the pipe dream, right? Continuous deployment is ideal that we can get software out there quickly, but it also has its downsides that if we screw up, you screwed up real bad. There's well-known ways to not do this here. Like you might deploy to maybe like 5% of your customers and make sure 5% of your people aren't screaming at you before you roll it out to 100% of people. We don't know why CloudStrike didn't do this. They're stupid, and we can make fun of them now because it happened to them and not to us. But again, that sort of thing. So just be careful, right? And that's the fun piece of software engineering where we get all these processes and tools and techniques and things around not just writing the code and being a code monkey, right? But all these cool things of how do we get software in people's hands, which is a lot of fun. So this is the stuff I was interested in. I worked on in industry, doing what we call DevOps sort of things. How do we operationalize all of our software? So that's good stuff. Okay. Where were we? Oh, testing, right? And getting our tests passing. So for the project, you'll be doing unit tests. Half your points come from actually testing your code. So you get points just to make sure that your code works, which you should have been doing anyway, but I want to make sure you can actually write unit tests. Probably no one else will ever ask you. I don't know that for sure, but it's good to do. Whether or not you want to go through the rigmarole of having a test class, sure, that's fine. The other really nice thing this lets you do, and one of the cool things with this idea of a solution is one or more project, when I build this solution, if this were can't talk, give me a second. If this was software I was shipping to a customer, when I build it, I exclude all of the test code. None of the test code goes to my customers. So in the release process, right, you've got a build and you've got a release. I don't know if you've ever touched release. Where is it? Here. It's probably in the configuration manager. So you can build a release version instead of a debug version. Right? Everything we've ever looked at was bin debug instead of bin release. You remember looking at any of that stuff? It says show explorer. Yeah, here's the debug bit. Here's my actual object file, the executable. No, that's not the executable. Where'd it go? Is it just the object file? It's been a little while since I played with this sort of stuff. Link file. Ugh. Yeah, all sorts of ugly things in here. Is it in this one? This x64? Yeah, there it is. Here's my executable here. Right? So if I wanted to give this executable to someone, you probably don't want to give them your debug version. That's all. It's got extra stuff here that you generally don't want them to have. Right? Nothing says you can't, but you can build it in a way that excludes all the stuff you don't want them to have, which is nice. So having a separate project to organize those things is really cool. Okay. All right, we got through that. Should we flip back over to the other one then? Let me go commit this. So here was, let me skip the week 2 stuff for now. So when you commit things, you can commit just certain files at a time if you want your snapshots to look a certain way, just like how that one looks here. So here's testing. Sorry, 1 second. So my wife called. She knows I'm in class, so hopefully nothing's like actually wrong. Cool. Okay, I don't know. Let's see if she calls back. So now that commit will just have just those files. I can come back and add these ones here in a second. So here's week 2 commit and push. All right, how far did you guys get with inheritance?
Not at all.
Not at all? You didn't do any inheritance? Okay. Anybody?
Prior to this class?
Just a little bit.
Yeah, in 100 or 150. Did you do inheritance?
Yeah.
Yes, you did. Okay, so some people did. Sure, that's fun. If you didn't, this will be brand new and it'll be a little awkward, but that's okay. We'll get through it. We've got a little bit of time here. It'll probably work. Oh, excuse me. So let me actually pull up the Zybooks here, because why not? Zybooks, I want my, not that one. Sure, not that one. There we go. Oh, it does have unit testing, right? They probably didn't use the unit test class though, did they? What did they do? Bad tests, sure. Okay, they just wrote another main file. Yeah, they just wrote their own poor man testing. That's fine. Sure. Right, where's is it in here? Sorry, I was making sure it's in this section. Is it not? This static. Oh, it's in chapter 10. I'm really confused, folks. I'm tired. We don't get till okay. We don't do inheritance till chapter 10. Well, it's good I looked, because I was going to jump ahead a bunch. So we can just do chapter 6. So our pointers will be a little bit more boring, but that's okay if we're not doing inheritance. They'll be much more fun when we do inheritance. This is good to look. Good to look. All right. Helpers, constructors, separate files, overloading, initializers, this. Oh, yeah, there's a section for this. Someone said they didn't talk about this before, with your this and the arrow notation. Again, I like using it. Some people don't, and that's okay. I like when my names match, right? So if you make your names match, then you got to use your this. You don't have to use it if they don't match, but that's fine. You can use it anyway, anytime you want. Operator overloading is really interesting. We'll do some operator overloading for the project to say, hey, I want to say this is what the plus does for my class. So you can take one instance of it, add another instance of it. It doesn't make sense for every class, but for some classes it can make sense. We can do operator overloading. Vectors, why do we throw vectors in here? This organization here is a little weird, I'm sorry. Did you talk about static data members and functions? Okay, that's okay. So we cover some stuff, and then we come back to it later. Right? I've done 150 before, so it's just weird how different it is for all of you. Because I thought we all covered the same stuff in 150, but that's okay. That's why we've got it here. So let's look at some static things to start. We won't go super far with that, which is nice. We don't have to do too big. So we can do operator overloading, and we can do static data members. That sound good? Okay. The comparison operators, these are fun ones too. So if you want to say how you define if two things are equal, this one's a really good one here. So this is the Boolean operator. I just want to steal their code because it makes it easier to type than me having to do this myself here. All right, so let's go and add another class here. So let's go add a header file. And we want this one. How about we had chair? Let's make a chair file here. So a class for chair. And then we've got our private section, we got our public section. Private section, we probably have a string for color of the chair. We gotta include string. C++ is stupid. Include string. Who doesn't use strings? Okay, so we got a string for color. We probably have an namespace. Standard. Okay, there's a standard library. It's in the standard library. Why do we have to include it? Int for maybe the height of a chair, because chairs can have different heights here. And I would strongly encourage you to, anytime you're using a unit of measure, tell me how you're measuring it. Right? So include that in the variable name to make it very clear this is height in centimeters. Or I'll just do cm because spelling centimeters is really obnoxious here. Right? So I will specify my height in centimeters for this chair here, because that's useful information to have. If you say height of a chair is 12 centimeters is wildly different than 12 inches, which is very different than 12 meters. Right? Those sorts of things cause rocket crashes, believe it or not, because Americans are stupid and we still use our system. We haven't converted to metric yet, and we crashed a rocket because of it. Right? We work with international people all the time, and like someone forgot to convert to metric. This was years ago now, but still, it's just always depressing. So things about chair, we got height, we got color. That's probably fine for now here. So now we want a chair constructor that takes no arguments, or we can take some arguments. Maybe we'll take a color and an int for height in centimeters here. We'll say my this color is the color, and my this height in centimeters is the height in centimeters. then we need get and set methods. Oh goodness, I don't want to write get and set methods for this. I'm not going to. We're going to make chatbot write it here. Is that okay? Okay, no one yelled. That's fine. Does it give me the generate? One of these tools generates it for me. It does not. Quick actions, no. That's fine. Lame. Write, get, and set methods for the attributes of this class. And sure, here's my entire prompt here. So we'll drop it in a code comment here. This was umgpt. I don't care if the formatting is pretty or not. It doesn't matter. Nobody cares. And we get and set methods. Yay. Look at that. It even left me a comment letting me know this is the get method for color in case you can't read get color. Right? It's the dumbest thing. Like, I don't understand why someone would think that's useful. But chatbot loves stupid comments. So, which is helpful because when you give me code full of stupid comments, I assume chatbot wrote it, right? Because you guys don't add stupid comments because I've never asked you for stupid comments and you wouldn't put them in if I didn't ask you for them, right? Everyone's smiling and nodding. If you add comments, I apologize. I probably won't make fun of you much. It's okay. If it's a useful comment, please add it. You're welcome to add useful comments, but adding a comment that says this is the get method for color, that's why it's stupid and I make fun of it, right? Is that I'm not, okay. I feel bad sometimes, but that's fine. Sure. Oh, it even did fun things for us here. So this is a constant string reference to new color for setting, sure. So you give me the string reference, you don't need to give me a copy of it, which is nice, sure. And I'll set that equal to it, a constant value here. Set the height in centimeters. Now this one we care about. This one's a little bit more interesting, right? One of the things our class should do is maintain its integrity. You can't have a chair with a negative height. Physics wants a word with you, right? It just doesn't happen. So we want to check, hey, if my new height in centimeters is greater than 0, now I'll go set the height here. If it's not, to do exceptions. We'll deal with it next week with exceptions. We'll come back to it, right? But if it's less than 0, I'm just going to ignore you. It's not ideal, and we'll next week we'll talk about the right thing here, but that's fine. So setting, I don't care what the color is, right? You can give me anything because I don't know all the names of colors. When you read a box of crayons nowadays, like, I guess somebody needs a job at Crayola to come up with new words that sound like colors. But like, there's no list of red, green, and blue. Like, if you can have a red chair or a black chair or a blue chair. Sure, we can validate it was red, blue, or black. Sure, it doesn't matter at this point here. So set the color to anything you want. We'll pretend like it's probably a color, right? Cool, so we got those ones. That was a lot of extra white space there, that's fine. Now, how do we compare chairs? Right? That was the whole thing we started with here. So let me go back to our SciBooks and shamelessly steal this here. So we're gonna add an operator overload for chair. It says, hey, I want to compare two chairs here. Why is it yelling at me here? Too many parameters for this operation. Really? Did I not, am I missing a semicolon somewhere? What's going on? I feel like it shouldn't be missing too many parameters. What did we do wrong? Oh, yep. So sorry, this was outside of the class code here. That's right. Now it's happy here. So we're going to define how we define this operator outside of the class. Why is it outside of the class code? Is that right? That one feels weird. I guess, sure. We'll just smile and nod. That's fine. We'll go with it. So to compare then, I want my get height in centimeters if it matches the other get height in centimeters, and my get color is equal to the other get color. And left-hand side, right-hand side, I feel bad with these notations, but sure. LHS, left-hand side, RHS, right-hand side. So the left of the equals, the right of the equals. Yeah.
I think, I'm not sure, but I vaguely remember that if it's outside the class, then you have to do something on top, like next to using namespace.
Let's see. I don't see anything in here. I know it's been a little while, and honestly, I didn't practice it beforehand. So we'll try it. Maybe it'll work. If it doesn't, then we'll go Google and see what's going on here. Do you think chatbot knows? Let's ask chatbot. Let's ask the chatbot. Here we go. Why is defined outside of the class scope? We'll find out here. Maybe. We made it think real hard.
Struggling.
Wow, it's on the struggle bus. Come on, ChatGPT, you're supposed to be smart. Hey, there we go. It's common practice. Symmetry, flexibility, and consistency. It sounds like it copied off a textbook somewhere. A non-member function, you allow it to work symmetrically, so left and right will work without conversions. Okay, sure. Comparing a chair object to make sense contextually. Sure. Works with encapsulation. Sure. Implementation convenience. Oh, look, it even wrote it for us. How fun is that? Define outside the class. If chair 1 equals chair 2. That was not super helpful. Well, you can keep it as a friend function with access. Here. There we go. Sure, that's fun. Let's try it and see if it works. So we've got our chair header file. Let's go add a new, don't we have a source file in here? There we go. So let's include chair. I don't think that was super helpful, was it? Chair. Let's make a chair. Chair. Eric's chair is, what color is this one? Red. I had to go look. Red, and it is probably like 50 centimeters off the ground right now. It's not super high off the ground. Like another chair, Bob's chair. Now, if we want this to be not equals, right, we'll give it something other than that. So how about blue and 50? It shouldn't matter to anything here. And let's print and see, or if Eric's chair is equal to Bob's chair. Print, oh goodness, see out. Equals. End line, otherwise, see out, not equal. And they shouldn't be equal, right? Not equal, all right, easy enough. And let's go make another chair here then. Let's see if we can get one that is equal. So another chair, I don't know, matching chair, red and 50. And let's see if Eric's chair and matching chair match here. Matching chair. And we get they are equal. Yay! So we're able to say this is how you can define if two instances of a class should be equal or not. Kind of useful, depending on what we want to do here, because without that, they're only going to be equal if they're the same reference. Right? They actually literally point to the same one. We want to say, do the values match? Are they equivalent here, but not the same object in memory? Which is nice. And this will be very useful to do a lot of this later on when we start getting into some more of the data structure sort of things. Determining if something equals something else is very helpful as we go. That one's lots of fun. And then how about some of the comparisons, right? Should we do like greater than or less than, right? We can say operator less than. So now this one here, we don't care about the color at all to say if it's less than or greater than, or maybe there's like one super color that's better than the rest, but that seems slightly far-fetched here. So all we want to do then is compare the heights and say, okay, it is less than if left is less than the right. Cool. And then we can also compare less than or equal to. I think we get that one right. Less than or equal to, sure. We could compare, yeah.
So this is overloading? Or is this
Yeah, so we're overloading the operation for our class. So the default version is going to, I don't even know what it does with less than. It might be like, is the memory location less than? I mean, it's not useful if you don't implement it here. Yep. All right, so less thans, and then how about a greater than here? Now, in this case, it's really easy to flip the greater than. If you want to get fancy, you could do less work and then call your less than function, but as a not, right? If it's not less than or equal to, it's got to be greater than. It gets to be a little awkward and confusing sometimes, but if you're comparing like 7 different attributes, that's kind of nice and helpful. Again, maybe just consider being lazy. Not less than or equal to means it is greater than. Just consider being lazy. But at some point it hurts your head to think about, so we'll just go this route here. And then one more, greater than or equal to, right, is the opposite of less than. And we should be able to go from there. So we got the operator equals. I don't remember if we get the not equals for free or not. Let's see. So how about not equals? Yeah, it doesn't. Okay. Doesn't match the operand. Okay, so that's good. So we got to go add our own not equals, right? Now with the not equals, right, Boolean operator not equals. Is that one going to work for us? Does it give us? Let's try it. Oh man, I have too many parentheses here. With this one now, I would definitely recommend being lazy. I'll just say not left-hand side equal right-hand side. So, oh, sorry, not. No? I don't get a parentheses this? Come on, let me be lazy. There we go. This one just do the not, right? That's probably fine to be lazy, right? Opposite of equals is not equals. That one should work out pretty well for us here. So now we should be able to compare our not equals. Right, compare equals, compare less than, compare greater than. So any of the operators you want, I think you can overload like modulus and other nonsense. I don't know what one chair mod another chair would be, the remainder of dividing one chair from another, but sure. What is multiplying one chair by another? I don't really know. Maybe if you get to like geometric shapes, it might make sense. But at that point, I'm a little confused. So overloading our operators is really fun. Why are some of these blue? So I get distracted by the weirdest things. I'm sorry. I don't know why those are blue and those aren't, but it should be fine. Does it run? Oh, there's build errors. Okay, I never finished this one here then. Not equals. Constant. Is that one not working is why? I thought it was. What was the error? All right, I got to start at the first one here. Sorry. Missing a semicolon. Operator less than? That one looks fine. Okay, well that explains why it wasn't blue, because I didn't actually understand it. Is this not it for the operator? If I comment this one out, does it work? It does. My build errors go away. I don't know. Overload the not equals operator. Let's ask the chatbot.
I'm pretty sure it's because it's missing the second parentheses.
Missing another parenthesis?
Yeah, there's the first one, but then it doesn't have another one.
This one here?
No, for the not equals.
For the not equals.
It's like
think
full
the
operator,
curly
then
braces.
parentheses, then
The curly
the
braces.
curly braces.
All the way on the right.
All the way on the right. I'm super confused. Here's a parenthesis, here's a curly brace.
And there's not a second curly brace.
There's no closing curly brace.
Oh my goodness. Curly brace. Okay. Thank you. Goodness. Is that now happy? Does it run? All that for curly. This is like 7 errors for a stupid curly brace. I told you folks I'm tired. I'm sorry. Try ED. There we go. Reformat. All right. Cool. Okay, so we didn't even need your code. Go away, chatbot. You're still thinking anyway, or something. Maybe we broke it here. All right, is that good enough? You okay? I'm tired. Can we quit a little early? Okay. It's been a week. So operator overloading. Next week we'll talk about exceptions and pointers. Get to our first project dealing with pointers. Lots of fun. We'll try and make my computer crash. It hopefully won't actually crash, which is a lot of fun because you can do bad stuff in C++. Should be a lot of fun. I'll see you folks Tuesday.